Welcome to this lecture, Designing Characters for Survival Games. So this is basically a case study of the VoxelVerse character design, the smart contract of it, and deeper diving into some of the methodologies, why we did certain things, and the blending, of course, of the gameplay and the tokenomics that we've been going through over the past few lectures. So, what makes survival games compelling? There's a lot of metrics to survival games, RPGs. There's a lot of stats. There's a lot of things that can be directly uh, put on chain, verified by other game players, the game system itself. So it's really cool in that aspect. And if you take into, say, like a card-based game where there's a lot of stats, there's a lot of things you can put on chain, there's a lot of things that you can verify and component and compartmentalize. So we're going to go through like what makes survival games compelling, why character design is central to survival loops and pretty much all games in general. So let's look at some pillars with regards to, traditional games. So we're going to have some of our core attributes like health, stamina, hunger, thirst, some skill trees, emotional progression of the player throughout the game, and some risk reward loops and permadeath, right? So these are kind of like some of the paramount parts of a character that you would design with regards to a survival game. So, how can we add Web3 to this mix of the classical character design and then adding these Web3 enhancements to it? Well, the first and foremost, and that you hear all the time, is that you have true ownership with on-chain identity and on-chain verifiability. So, take into account in traditional games, we have our game server that holds a record of the player with their stats and everything like that. If for whatever reason the game developer is no longer willing to fund the game, or for whatever reason the company goes defunct, the servers usually turn off. And when those servers turn off, all of your players' stats are gone. With on-chain mechanics, the blockchain stores all this data on chain in an immutable record, or there's opportunities to upgrade. But the main carry away is that if the game goes away, the abilities, the stats, the player, the components, the tokens, all this stuff is on chain and basically lives forever. There's immutable progression, as we talked about before, economic utility, earn, spend, grow. This is kind of your economic loop. And then there could be governance over the character metadata as well, like adding more components to the original design itself. Or this may be with, say, a token allocation or a growth progression, and the community would like to see different types of changes, and they put a proposal. If that proposal passes, then you can upgrade the contract. So the key components of a Web3 survival character, the ERC 721 as its identity. So an ERC 721 or a non-fungible token is a single token. So every token is unique. It's non-fungible. Stats, some of the base stats is that we could have the player's experience, we could have heat, hunger, happiness, and these are directly taken from the Voxel's main character. The metadata for his visual identity, and this is also going to be in regards to the on-chain verifiability. So say like you go to like OpenSea and you see the NFT, then it'll have like the stats of the player that are being written to within the game, updated on chain, and then verifiable on something like OpenSea itself. And then there's the ability to upgrade, and this is done via the smart contract. So we also have a drip economy, and this is based around a habit loop, which is a Web3, mechanic. Like we're making these as we kind of go. But a habit loop is in Web3 games defined as something that a player needs to do consistently in order to gain something. So in this drip economy, the habit loop is that for each 24-hour period, a player can log into the game and get a drip of the token. If they happen to not log into the game within that 24-hour period, then they lose that ability to claim those tokens, and then they basically have to start again. As days go by, there also is a degradation to the player's health as well, to the point where the player would die. They would actually have to use tokens to revive their character, and then it kind of starts again. So habit loop design, it has this mix of rewards versus punishment. Now, we can look at something that is a new term as well. It's a progression mechanic. And this will have tied to it the player's experience and level-based, on-chain activity. There's earning of NFTs, items, reputation score can also be increased with this as well. You can kind of envision some, core things that you could do. So say that there is a, 10-day player login streak, and you want to earn a badge to the character, and then that shows the community that this is really an engaged player. You can gamify the, survival stats as well. And as we mentioned before, like say that you survived, 10 days and didn't have to revive your character, or, 30 days, or, the ultimate is, 365 days in a year. And then you say you have 1, 2 years, and then 5 years, and you can kind of, incentivize and give the player rewards based on their survivability within the game. But also this shows that this character is, of an elite status, and everyone can go on chain and verify and view this, right? It's pretty cool. Designing for permanence, soulbound or, optional trade. So a soulbound token is a token that is issued to a specific wallet, and it's non-transferable. So it's bound to the address. Or you could have, an optional trade, or you can, have a mechanism where this might be something that's voted on by the community. Death equals a penalty or a revival fee. Now, in traditional games, usually there is a revival fee. You are gaining, tokens within the game, and then you're using these in order to, revive yourself, or say that like there's like a health pack in a game, you use your health pack to revive yourself. The same kind of mechanic, but just remember that there's the balance that we need to do with these particular items, because all of these items themselves are, they're on-chain collectibles to a certain extent. And we don't want to overinflate these particular things with inside of the game world. So metadata evolves with player history. So the player's XP, the badges that they're getting for surviving a certain amount of days, all these can be taken into account. Token integration. So the voxel token use cases, we have minting. You're using the voxel token, crafting, healing, upgrades, resurrection. You're all using the voxel token to purchase specific items within the game. and to do these particular actions. So as we've been talking through the design, the token engineering, the tokenomics part is where, there's, the issuance and why the token exists and what the token is being used for. And then all these other pieces are built into, especially with Web3 games, where the game loop, the economic loop, and then the token itself are, bound in this trifecta, and all pieces are needed to, keep this thing balanced and together. So we'll go into a little bit more of a case study of the VoxelVerse main character token. We will define some of the, the minting, free, paid tiers, the daily drip, plus the misclaim penalty, and a balance in the incentive loops, or to the best of our ability. So player psychology in Web3 survival games, there is a sense of scarcity. Also, when we're taking in this kind of like emotional weight, there are items that there is only, a set amount of, and the scarcity component with the land that you have itself, you need to, strike this balance of the things that you want to have within the game and the things that you need to have in order to get the things that you want. So there's economic risk boost engagement. So this economic risk of, losing the, drip that you're going to get for each logged in 24-hour period boosts the engagement, because you'd rather have, of course, those tokens to be used at a later time, keep your character alive, because as this accrues, there's also other incentives for doing so. Then that does boost engagement. So it's kind of one of those scarcity things. If I don't get in and get this, then I'm going to lose it. And that thought for the player and the in-game character itself will drive your, players to come back in. And then there's this on-chain component, which has the verifiability. It also gives the accountability as well. So as a conclusion, Web3 enhances our survival character design by, a few factors here. It has the ability to define true player ownership of these assets. And when, a friend of yours is saying that they're doing all this stuff, you can call that out. You can go on chain and verify these metrics that your friends are saying. There's a sense of permanent consequential choices that we have. And we also have, which is, of course, the best part of Web3 game design, is that this community-driven narrative depth that we get from having players that are a part of the game, a part of the progression of the game, and a part of the overall survivability of it. So that is the lecture today. Hope you guys got a lot out of this. Web3 game design is in its infancy, really. And it's really cool to see what we as, traditional game designers and developers can use Web3 as this enhancement protocol, giving massive value to our game players. Now, what did you guys think about this lecture? Please, hit a thumb up on this, subscribe to the channel, and leave any comments down below, and I'll get back to you guys. Until the next one, that's it.